Servidyne Corporation here in Atlanta, Georgia. Servidyne specializes in retro-commissioning, energy modeling, energy audits, lead consulting, Energy Star certification, and demand response. Barry's been a longtime friend of Service Professional Group, conducting several sessions over the years. He currently serves on the ASHRAE committee that wrote the standard for commercial building energy audits. He's the past chair of the Lead Energy and Atmosphere Technical Advisory Group and was one of the principal investigators for ASHRAE's research project on HVAC equipment service life, something that we use on a regular basis. So it's my distinct honor and pleasure to introduce Barry Abramson.
All right, thanks, Brad. So my basic introduction is I've been around forever. And I have had a long and happy friendship with Brad and with Service Professional Group, and really appreciate the opportunity to speak with everyone today. The topic for this session is building reopening realities. And I wanted to spend some time today talking about the pandemic, how guidance has evolved throughout, what we're seeing out there in terms of building owners and operators, how they're navigating through it, and how we and you on the service provider side can best focus in order to bring the most value and the most technical resources to buildings as they enter into this coming period. And even though the title of the presentation is reopening, I've been schooled by our clients, the building owners and managers, that they never use the word reopening in the commercial real estate industry because that would mean they were closed and they shouldn't have been collecting rent. So we're supposed to use the term re-entry instead of reopening. I've been very, very closely schooled on that. So I'm going to run through a few topics on some slides, but really want to have this back and forth. If you have questions or discussion points, feel free to bring them up, in the course of this, and certainly at the end we'll have plenty of time for some more back and forth. So to start off, I thought I would show a slide that has a little history to it. As Brad mentioned, I've done a few presentations to your group over the years. This was the cover slide for the first one I did, which was back in 2008. And this was a principals meeting that was in Southern California. It was a beautiful location on the beach near San Diego. And actually, Brad reminded me that at the time, I had combined going out to California with a tour of colleges with my daughter, who was in 11th grade at that point. So just kind of thinking about doing this discussion today kind of brought back that memory, and the 9 years of college she spent since then, getting 3 degrees and going through a lot of resources. But thankfully she made it through all of that schooling, and she's actually a nurse at this point, and she spent most of the past year in the COVID front lines in the emergency room dealing with COVID patients. So kind of appropriate for the topic of today's conversation. So throughout the course of the next few slides, I've got a few pop quiz questions, and these are rhetorical questions because unfortunately we're not in the same room. People can't throw out their answers verbally. But the first pop quiz, number 1, is what's wrong with this picture? So this is a picture I got recently from a client when I asked for typical air handling unit in a building that would show me the filter rack in the unit. Of course, when we're talking about pandemic readiness, there's a few things that jump out here that are very wrong. One is obviously the filter that's not exactly filtering because it's halfway off its rack. These filters look like they're, hardly MERV 8. They're probably more like a MERV 3. And in the background, the outdoor air dampers look very nicely completely shut. So to me, this was a good example of, some things that we don't want to see. But in fact, what's wrong with this picture is even more wrong is what's not in this picture, which is if you look at this building's website, they have a whole page on how great their COVID readiness actions have been, touting all kinds of bullet points about how wonderful, the wonderful things they've been doing to make the building as safe as possible and ready for tenants to come back in. And then here's what their ventilation system looks like. So this is kind of the theme of what I wanted to talk about today. We have been doing what we call building readiness assessments, over the past year for clients. We've done, I'd say, over 100 office buildings around the country. And basically what we've been doing is we developed a checklist to go through, what are the main items that people should be paying attention to in terms of both ventilation, air handling, on the HVAC side, as well as plumbing systems in terms of Legionella risk mitigation and other water areas of concern. So we developed this checklist of 30 or 40 items. And what we did was we would look at documentation from the building and set up a call with the building engineer, property manager, kind of run through these things and ask what the situation was in regard to all of these things. And then what we did was we would document what the current status was of these things, and then make recommendations in terms of what people should be doing. So we developed this kind of color-coded checklist. So the list of items is on the left, and then in green this is a particular portfolio of buildings. Each column represents a different building. So this one shows about 9 buildings in this particular region for this client. So each of the columns going down shows what their status was when we started the process. Green means the thing is in place. So, their outdoor air situation's good. They've got good filters. They're flushing their water systems, things like that. Red means it's not good and they need to do something about it. Yellow is maybe an enhanced measure that they could do if they wanted to go above and beyond. And then white is just things that weren't applicable to those particular buildings. So this is kind of a high-level view of where this portfolio stood when we did the initial interviews and the initial status report. And then what we did was we updated the checklist after the back and forth with the properties, kind of giving them guidance on, hey, you really need to open your outdoor air dampers. You can, upgrade your filters to MERV 13. You should be flushing your plumbing systems during low occupancy. Those kinds of things. You should, actually operate the ventilation fans that are in the elevators that haven't worked for the last 10 years. And so you can see the dramatic color shift. These are the same buildings, and now in green are all of the things that they wound up doing after we were through with the process. And what this told us was, in talking with all of these folks, that the guidance was very confusing, and it was a moving target. So that was one of the issues that led to some underperformance, in the initial interviews, but also that, a lot of people thought they were doing the right thing, but then when you dug into it a little bit, maybe not so much. So again, kind of a confusing situation for buildings, and we have a big role to play as service providers in helping people focus on the right things, understanding the important things, and making sure they happen. Okay, so here's the pop quiz number 2. Which of these is from pandemic guidance issued by either the World Health Organization, the CDC, or ASHRAE? Now I'm going to go through a list of items, and we'll think about which ones of these are part of guidance that came out of those organizations. Shut off HVAC systems. Operate HVAC systems 24/7 with 100% outdoor air. Provide ventilation 2 hours pre-occupancy and 2 hours post-occupancy. Provide 3 outdoor air changes during the unoccupied period. Provide 3 clean air changes during the unoccupied period. Well, you might already know the answer, but it's all of the above. Each one of these things has been put out by one or more of the main authorities in the industry through the pandemic. So you can, clearly understand why people have been confused. Initially, everyone may remember the scares about HVAC systems, spreading the virus through buildings. And a lot of people are saying, oh, we need to turn our systems off because we don't want the air handling units picking up the virus from one room and spreading it to another. And there were various news stories about the cruise ship and call centers and things that implicated the HVAC system, all of which were later debunked because it's never been shown that an HVAC system has actually transmitted viable virus from one place through a return air and then supplied it to another room where it was still viable and dangerous. So the shut-off HVAC systems, while it was an early guidance, was fairly quickly abandoned. Operating systems 24/7, 100% outdoor air, that's still something that people think is a major piece of guidance, but that's been long done away with in terms of really what people need to do to provide risk mitigation. And then these other things were more incremental refinements of what the guidance has been in terms of how much to operate systems before and after occupancy in order to purge the building of any kind of contaminants before the next occupancy the next morning. And we'll talk a little bit more about that. But it's always good to start with the fundamentals in order to provide a basis for why the guidance is what it is. When you're looking at indoor air quality, which also impacts COVID-19 mitigation, particularly in terms of the concern about airborne transmission, we're looking at 3 basic strategies: source control, ventilation, and air cleaning. Source control being prevent the stuff from getting in the building to begin with, or getting from one person to another. Ventilation being dilution of the air in the space with fresh air, and air cleaning being removing contaminants through various types of filtration. Typically what's been recommended is a layered risk mitigation strategy that is built on some kind of risk management pyramid. This has shifted through the course of the pandemic with different pieces of this pyramid moving up and down based on the science and understanding of how the virus was being transmitted. But at the base of the pyramid is that source control, which is screening people so sick people don't come into the building, distancing so that the people who are sick are not directly transmitting to another person, barriers and face masks also being modes of preventing that source from reaching another person. The next up is ventilation. The one after that is filtration. After that is hand hygiene and surface disinfection. It was originally thought that the primary mode of transmission was through surface contact. So there was a lot of emphasis on hand washing and disinfection of elevator buttons and doorknobs and things like that. That has now been downgraded in terms of level of importance. And then you have more higher interventions like UV-GI or portable HEPA filters, particularly in healthcare or areas of more of a risk situation. And then on top of that, you have other technologies that have been out there, and I'm not going to delve into this yet, but the question of whether things beyond the items in this pyramid are for real or snake oil is an open question and highly contended at this point in the industry. In terms of the ASHRAE Epidemic Task Force guidance, it has certainly evolved since the beginning of the pandemic. So back in April 2020, when ASHRAE formed the Epidemic Task Force, they issued their initial guidance, and the catchphrase in terms of airborne transmission was that it was sufficiently likely to warrant measures related to HVAC. But there were many unknowns, and the guidance was very conservative because of those unknowns. So they were pushing 100% outdoor air as much as possible. In addition to MERV 13 filters, they were encouraging people to operate their equipment 24/7 and to bypass energy recovery equipment. Now, that's been superseded by recommendations that were issued this year. And basically in April of this year, just a couple weeks ago, new ASHRAE guidance was issued, and a new statement was publicized where now ASHRAE treats airborne transmission as significant as opposed to sufficiently likely. Based on more research and prioritized risk reduction strategies that have been developed through the course of the pandemic, the guidance now says that masks are critical, that you don't need 100% outdoor air, but you need at least code minimum ventilation, that the importance is to provide clean air, which is a combination of outdoor air ventilation and filtration, that there really needs to be a focus on making sure that the HVAC systems are working properly, they're well maintained, they're properly commissioned and functioning, and that people should focus on what is proven to be effective and safe. In terms of the ventilation guidance, it's really a major concept that ASHRAE has been pushing is the air changes per hour. And so the guidance currently for operating systems outside of normal occupancy periods is that you want to operate to provide 3 complete clean air changes, which removes 95% of the contaminants in the space. And for some frame of reference, so there are different standards for different types of spaces, but a hospital operating room typically has a system that provides 20 air changes per hour, which means in 9 minutes, you get that 3 air change turnover. Whereas an office down at the bottom of this table with minimum outdoor air at a low load situation, you're only getting about 0.4 air changes per hour, which means it would take 7 hours of operation of that minimum outdoor air to provide that 3 air changes. So important concept in terms of how to judge what's going on with a ventilation and filtration system is the air changes per hour. In terms of filtration, the guidance says that you should use a combination of filters and air cleaners that achieve MERV 13 or better for the recirculated air. And the way I'm going to dig a little bit more into filtration, because when Brad and I were talking, I think there's been a lot of questions back and forth about filters and MERV ratings and things like that. So I want to spend a little bit of time delving into this. So the chart on this slide is from some research testing that was done of the filter efficiency for various MERV rated filters at different particle sizes. So each of the lines represents a different MERV rating, with the bottom one is a MERV 6, the top one is a MERV 16. And it shows that through the particle size range of really, really small at 0.01 microns up to 10 microns, these filters have various efficiencies of capturing the particles. So it's kind of counterintuitive. You'd think the smaller the particles, the worse the filter would perform. But because of the different physics involved in particle capture, they're really good at really, really small particles. There's a low point of their efficiency at small particles, and then they get better as the particles get bigger. So the problem is that the virus, you know, the aerosols that the virus is traveling in are in the range where typically these filters are at their lowest efficiency, in sort of the 0.3 micron range. So when we look at the MERV ratings, the table on this chart shows some different interesting numbers. So the MERV rating is based on ratings at different particle size ranges, and in the 0.3 to 1 micron capture range, a HEPA filter is more than 99% efficient. A MERV 14 is 75%, a MERV 13 is 50%, and a MERV 8 is not even rated at that small of a particle size. So that gives you a sense of why, you know, HEPA filters are, you know, so great in a hospital environment, but also why ASHRAE is recommending at least MERV 13, because that's at least getting you up into the range where you are capturing a decent amount of those smallest particles. So to bust a few myths, I took the next few slides from a presentation I did for a group of school facility managers. So it's the chalkboard motif here. But one of the things that we need to debunk, and we've actually heard from some clients, is they think, well, if I put a MERV 8 filter in and I put another MERV 8 filter next to it, then I get MERV 16 and I'm in good shape. So we say 1 and 1 equals 2, 2 and 2 equals 4, but MERV 8 plus MERV 8 does not equal MERV 16. So why is that? Well, MERV ratings are based on, again, a particle size range efficiency. And so you have 3 different ranges that the MERV rating is based on. The 0.3 to 1 micron, 1 to 3 microns, and then 3 to 10 microns. And MERV rated filters have to have at least a minimum efficiency rating in each of those 3 ranges to get that MERV designation. So for instance, the MERV 13 needs to have that 50% or greater efficiency in that smallest range of the MERV rating, which is 0.3 to 1 micron. If you put a MERV 8 and a MERV 8 together, which neither of which is rated for the smallest size, you're not going to get up to a MERV 16 rating, which is 95% or greater. There is a way to calculate a combination of filters to see what the composite MERV rating is. And so it turns out if you have a MERV 8 and a MERV 8 in series, it's actually equivalent to about a MERV 11. If you have a MERV 7 and a MERV 11, it's equivalent to about a MERV 13. So you can mix and match if it's totally impossible to get a MERV 13 filter into a system. There are ways to do things with pre-filters and final filters that can get up at least higher or even achieve that MERV 13 rating. But here's a quiz question. I didn't make this one of the pop quiz questions, but it is a quiz question. What is MERV 15 plus what equals MERV 8? So that seems kind of weird. How do you take a MERV 15 filter and turn it into a MERV 8 filter? Well, that brings up another important aspect of the ASHRAE guidance in regard to filters, and that has to do with filter bypass. So akin to looking at the importance of masks and what their effectiveness is or not, here's 2 pictures. One on the left shows somebody wearing an N95 mask that is not fitted to her nose, so there's a gap above that filter, which means it doesn't matter what the filter rating is, a portion of the air that person is breathing is unfiltered. So it kind of defeats the purpose of that high efficiency filter. The person on the right is wearing an N95 mask correctly, with the pinched section around the nose, and even has a face shield. So that filter, that mask is doing what it's supposed to. And a quick side note, that picture on the right happens to be my daughter. Okay, so how does this translate to filters? Well, one of the important pieces of ASHRAE guidance is to seal filters to prevent bypass. You can take a look at the picture on the left. Obviously, there's a big gap there. And the picture on the right, someone has gone to the trouble of taping each filter to the next filter. Tape might be appropriate in some situations. In other situations, permanent gasketing can be added. But whatever needs to be done should be done, because there was an ASHRAE research study done several years ago that showed that a gap between filters smaller than a ½ inch, which is not much, means that 20 to 25% of the air is bypassing the filters, because obviously it's going to go where it's the least resistance is. And that does actually drop a MERV 15 to a MERV 8. So you can have MERV 15 filters with a little bit of a gap between the filters, and what you're actually getting is only equivalent to a MERV 8. Okay, I want to talk a little bit about filter pressure drop, because we've got a lot of people with a lot of different views out there about pressure drop and whether a system can or can't handle a MERV 13 if it's got a MERV 8 now and things like that. So this is a really interesting graph. What it shows is along the left, the y-axis, it shows the initial pressure drop at a face velocity of 500 feet per minute in inches of water column. And the three data points along the horizontal of this graph are MERV 8, MERV 11, and MERV 13. And what this is showing is that for any given manufacturer of a 2-inch pleated filter, a MERV 8 could have a pressure drop of less than 0.2 inches all the way up to more than 0.3 inches. A MERV 11 has a similar range. You could get a really low pressure drop MERV 11 filter at 0.25 or less, or you could get one at close to 0.4. And similarly with MERV 13, you can find MERV 13 2-inch filters at under 0.3 inches of initial static pressure all the way up to 0.45 inches. So that means you can't answer the question of can the system handle a MERV 13 just by looking at what it has now and saying, oh, that's too big of a jump. It's going to cause a higher pressure drop, and I'm already on the edge with that fan, so I can't do it. So how do you figure this out? Well, there are charts like this that should be available from the filter manufacturer, and typically on their websites when you download the filter specification sheet, or sometimes it's in the filter brochure. They all look something like this. These are 6 actual excerpts from filter cut sheet or sales brochures, and they will show the pressure drop along the y-axis, and typically it'll be the feet per minute or CFM that filter is rated for along the x-axis. And you can figure out from these graphs, from the specs, what is the pressure drop for this particular filter model at the design CFM or air velocity. And again, there's a wide range of pressure drops in the market. There are some filter manufacturers that have even a MERV 15 filter with a pressure drop like on a 2-inch pleated filter that is lower than a lot of MERV 11 filters out there. So they're a lot more expensive, but they are out there, and so you can't just rule out the possibility of upgrading the filter MERV rating without looking into what the specs are, particularly on the filters that are being used now, and then what alternatives are available in the market. Okay, so a couple other pop quiz questions, and then we'll open it up for discussion. So again, as I said earlier, the air changes per hour is a really important factor or feature that goes into figuring out how much ventilation air is needed, what level of filtration should be applied, and that kind of thing. So the other really important term is clean air delivery rate, which is basically equivalent to the CFM of clean air. And what is clean air? So clean air is a combination of outdoor air and filtered recirculated air. And a clean air delivery rate is going to be 100% of the outdoor air plus some discounted amount of the recirculated air based on the filter efficiency. So for example, if I have a system that has 20% outdoor air and MERV 13 filters, and we know the MERV 13 filter has 50% efficiency, I can take that 80% recirculated air and say I've got 50% efficient MERV 13 filter on that, so I can count 50% of that air as clean, which means I've got a combination of the 20% outdoor air and half of the return air. So that's really 60% of the air would be equivalent clean air that I'm delivering to the space. And the key calculation, again, on air changes per hour is to figure out how many clean air changes per hour is my system providing. And the gold standard is to get at least 5 clean air changes per hour. If you get 5 or 6 clean air changes per hour, you have an excellent situation, because basically what that means is every 10 or 12 minutes, you're completely replacing the air in the space with clean air. So the question that's posed is, whenever you do a clean air change calculation, you're looking at the portion that's coming from outdoor air and the portion that's coming from your filters. So we have 2 cases here. We've got one with 30% outdoor air and MERV 11 filters, or one with 20% outdoor air and MERV 13 filters. So it turns out that these 2 cases provide the same clean air delivery rate. The question is, in the pop quiz, which one uses more energy? Because there's another myth out there that says, oh, if I upgrade my filters, it's always going to cause an energy penalty. But if we're getting the equivalent clean air from these 2 situations, the first with more outside air at a lower MERV rated filter, or less outside air at a higher MERV filter, and that equates to the same equivalent clean air delivery. Well, if I'm in Southern California, maybe it doesn't matter too much, but if I'm in Canada or New York or Atlanta, where I've got to spend a good bit of energy to condition that outdoor air, then it might actually save energy to put MERV 13 filters in, because I don't need to bump the outdoor air up in order to deliver that same excellent amount of clean air changes per hour. Okay, I know that was going through a lot of material in a very short amount of time. I just have one other pop quiz, and then we'll open it up for discussion. So this pop quiz is it too dangerous to change filters? Which is another issue that we've heard out there quite a bit. The answer is no, but you should take certain precautions that we didn't need to worry about before. So here's the ASHRAE guidance on filter replacement during the COVID-19 pandemic. It's that it is not necessary to suspend HVAC system maintenance, including filter changes, but additional safety precautions are warranted. And the key provisions that are at this ASHRAE link that has the guidance is to make sure that people are wearing appropriate PPE, that you could consider using a disinfectant before they're removed, that they can be, filters can be bagged and disposed of in regular trash, and that the maintenance folks should wash their hands with soap and water, or use alcohol-based hand sanitizer after changing the filters. So there's some common sense, but certainly important to keep changing those filters. And again, this is not because these precautions are not because it's ever been shown that live virus has been transmitted, through filters and on back into the space. But it is a prudent precaution to assume that there could be virus deposited on the filters in the air handling system. So with that, I will open it up and see if we've got questions or controversies or discussion.
All right, everybody, what's some questions that you might have? Barry, I have one.
Okay.
So this this pressure drop across different filters, is there the 6 that you showed, were those all different manufacturers?
Yeah, I mean, we basically, there's some manufacturers are more difficult to find that information than others, but most of the major filter manufacturers have those, spec sheets on their websites. And, some of those were, on AAF Flanders, Camfell, Tridem, trying to think of some of the other brands that those come from. But I think, pretty much we've been able to find them, or if we can't find them, we call the, the manufacturer and they've been able to provide them for us.
Mm-hmm. So the important thing would be to determine what the current filter uses in terms of a pressure drop, and then try to match that with a higher rated filter then.
Right. I mean, there's a couple of things to consider. So there's usually the filters have 2 pressure drop ratings. They have the initial pressure drop and the final pressure drop. So, that initial pressure drop is important, but also looking at the final pressure drop because, if let's say the existing filter has a final pressure drop recommendation of 1.5 inches, which is when it would need to be replaced. But you put in a filter that's recommended, well, let me go the other way. Let's say the one they have, needs to be replaced at 1 inch, but the one you're going to replace it with could go up to 1.5 inches. You might still need to replace it at 1 inch because that would, hamper the system functioning if you let it go higher than that, which could mean that you need to replace the new filters more frequently than you replace the existing filters because they're catching more stuff and they may need to be replaced more often. So, and we talked about this a little bit earlier. So the filters cost more, they may need to be replaced more frequently. That is an added operating expense, but what we've seen, through the pandemic is this is a very relatively minor issue for owners that are trying to do the, due diligence to make their buildings as safe as possible and to give their occupants as much, confidence in what they're doing. So to me, upgrading the filters and maybe spending more on the filters and replacing them more frequently is a no-brainer.
And everything that we've talked about to this point is, I'll say, pretty much proactive preventive maintenance, the things that we do on a daily basis then.
Yeah, I think the thing that I think has been the most frustrating to us when we're in conversations with building owners and managers is they want to step over the fundamentals and immediately go for some kind of magic bullet. And that's why when I showed that kind of before and after of these building readiness assessments that we've been doing, it's such a stark situation where you assume that people are doing the basics, like maintaining their equipment, making sure it's functioning properly, making sure the outdoor air dampers are doing what they're supposed to do, making sure the filters are actually installed properly. The basic things like that, that so many buildings, if they're doing it either in-house or they have a contractor that hasn't been paying attention, are not doing those fundamentals, but they want to do something to install some some device that may or may not, be of benefit, but is certainly not as important as making sure their fundamental, systems are working properly and are properly commissioned. And or if they have, deferred maintenance or something that's malfunctioning that you've told them, they should be replacing that control or that sensor or upgrading this or that, and they just keep deferring that. That's really a lot of what we've seen is that people don't look at the basics and they immediately go to something else. And when really the fundamentals are super important.
Barry, this is Dave. I just want to be clear on the pressure drops, these filter air pressure drops. Now, and the reason I'm asking is I had a customer here recently ask why they shouldn't go to MERV 13. I mean, the equipment's very old. They have difficult times keeping the equipment running, but currently they're getting MERV 8 filter changes twice a year. Would there be any reason not to go to a MERV 13 if we could persuade them to increase the number of changes per year, as you just mentioned?
Yeah, no, the only impact that a filter has on the system is pressure drop.
That's it.
So if the pressure drop can be taken off the table because you look at the rating of what they've got and what alternative is available and it's equivalent or it's a smidgen higher, then it doesn't matter how old the equipment is. It doesn't matter if it's on its last leg or it's it's maxed out and can't put one more CFM out. You're not doing anything to it that's going to make it work harder.
Okay.
Now, but you are correct. You may need to replace the filters more often, but the filter itself, in terms of, you might actually have a slight benefit when you put it in initially because it's going to be clean and it's going to be at that initial pressure drop, and the filter, the MERV 8 that you're taking out, is probably not going to be at its initial pressure drop. So in the immediate change out, you're probably doing better in terms of resistance.
Got it. Thank you.
I have a question.
Uh-huh.
On the building readiness assessment, is that something available, like an available resource that we could use or get in an email maybe?
It's just sort of you mean that checklist that we used?
Yeah, I couldn't see the details on it, but I was wondering if it's something that we might be able to print out and use for ourselves.
Yeah, I mean, it's something we developed, internally. I'd be happy to send you like a blank so you can see the kinds of things that, that we've gone through with buildings. Sure.
Yeah, that would be great.
Okay.
Barry, you can send that to myself or to Emma, and we can distribute it.
Okay.
Now, you used a lot of technical terms throughout the presentation, but one that I wasn't familiar with. You said a smidge over on the resistance. Is there a specific micron attached to that smidge?
Now you can tell I'm an engineer, not a scientist. Smidge is probably the most precise word you could ever use as an engineer. No, you will see when you look at these filter spec sheets that they are, typically the pressure drop is given as 2 decimal points. So you may have a 0.30 inches of static pressure and another one might be 0.29. That's what I call a smidge. Now, if you have one that's 0.18 and you have another one that's 0.30, that's significant.
Thank you for that clarification.
Okay.
Anything else? We'll let Brian Glenn, you have nothing to add to this conversation?
No, Brad, I'm just enjoying the show. Thank you for asking.
Just enjoying the show. Okay, very good.
Okay, I mean, I could stir things up for another few hours, like by trashing bipolar ionization, but I was warned not to do that.
So Frank Wendt, I have a question for you. So are you changing many filters out to a higher MERV rating?
Yeah, we do have quite a few customers that had requested that. Of course, they they don't want to put the work in as far as doing studies on the buildings, because most of them are property managers that, you know, they just want to make it happen remotely. You know, they're not on site. So we do cautiously do it. We do let them know that, especially if it's an account, and most of these accounts happen that are pretty current to us. So, you know, we don't have a lot of history on them with their equipment. So, you know, we'll let them know we can do it, but your, you know, standard 5-ton non-high static rooftop unit may stumble if we get, say, sub-zero, or we get 95 plus humidity in Chicago. You know, that's, you know, like Georgia, you know, same kind of weather going on. Yeah,
Except you had snow yesterday, right?
Yeah, and more today we're supposed to get, but.
Well,
but
no,
yeah,
that's a good point. You know, we have the challenges are the really small equipment, what, you know, like water source heat pumps or fan coil units, package terminal air conditioners. Those are going to have a really hard time. Some can get to MERV 13, but it's going to be more tricky, especially if they don't even have a MERV 8 now. I mean, if they've got less than MERV 8, they probably have virtually no pressure drop because they're not getting hardly any filtration. So those are going to be kind of out of the question. But rooftop units, you know, really got to look at what they got now, and certainly the larger rooftop units are game.
Yeah, but some of the smaller stuff, I mean, we worry too, because a lot of times they've been changed out already, and it may not necessarily be what the ductwork design and all that was for, so it might already be struggling. But, you know, again, we go in and offer it cautiously, you know, and let them know that we're not sure, especially the people that ask us. If we go to approach them on it, then, you know, we'll do our homework first and present it to them that way. But yeah, that was a big thing. It's still, if anybody's making MERV 13, let us know so we know where to get them. But, you know, we've been, our office has been on back order, I think, since COVID started.
Yeah.
We've gotten a few, but, you know, doing the best we can. You don't want to talk about the bipolar thing. That was, you were told no, huh?
I mean, I can talk about it, but I don't know. If,
I don't know.
You might not have
We'll just leave it as a snake oil thing. It was on your list.
yeah, I didn't say what was snake oil.
Yeah, I do have meters though to read those. To read snake oil.
Okay.
Larry, I do have a question about that, because earlier in the presentation, you made a comment about using a combination of filters and cleaners. And, you know, when I heard that, the thing I thought of, well, you know, a MERV 8 and some bipolar ionization or some other type of air purifier. What can you speak to that? Because now I'm a bit confused that you're saying the bipolars are something you could talk about for hours, maybe negatively. At least that's my takeaway. But go for it.
Yeah, I think what ASHRAE was referring to there is probably mainly filtration plus UV of some type.
Yeah.
You know, I don't know if, you know, ASHRAE has kept away from recommending anything beyond UV in terms of technologies like, you know, bipolar ionization or the dry hydrogen peroxide or those kind of things.
Okay, got it. Thank you.
And some of the UV stuff too that I was going through, you know, of course, through this whole thing at first when everything was shut down, we had nothing but, you know, time to read about everything. The UV, you know, that kind of deceptive in my eyes anyway. It works well, but when you look at the airflow and they say 99% kill rate, but then you find out it's only, say, within 6 inches of that bulb, and then you find out your ductwork is 36 inches. And then you find out that you have how many inches that weren't exposed to that 99% kill area. You know, so
Yeah, no, I think, no, that's a great point. I have a whole set of slides on UV too that I didn't throw in here, but look, UV is great for killing stuff on coils and drain pans and stuff like that. But if you just put a system in that was designed to do that and then say, oh, it's got a 99% kill rate for on-the-fly virus, then that's just not reality. You have to design it totally differently, and you have to beef up the number of lamps and make sure the coverage is completely covering the airflow that's going by at 500 feet per minute or whatever, and you have enough intensity of the UV to get that kill rate. So it's multiples of what we used to consider normally, of UV installation in an HVAC unit to get that kind of disinfection. So, we generally, we like UV for the old-fashioned purposes of killing stuff that's growing on surfaces in an air handling unit, but we have not really been fans of trying to install it for COVID. And it's the expense of doing it the real way to get the right kill rate, is typically, from what we've seen, is $1 to $2 per CFM to install one of those higher powered UV systems. If you can get it in the unit or the ductwork and, get it situated right and make sure it's not shining on anything organic that's going to degrade.
yeah, one issue with that is the maintenance cost too, right on that, because after a year, your lamps aren't as, so then that's a huge cost too. So it's going to be an adventure for the people that we did that for also in the future, because you're going to end up with a bunch of sockets that have burnt out bulbs and, and with the spraying the filters, what we've been doing is IMS3 from New Calgon, little concentrate bottle. It does kill SARS-2, that I don't know, by now they may have tested it with actual COVID, I don't know, but it has no odor. It's an ice machine cleaner, right? IMS, that's what it stands for. So the guys have been using it. It's great because one concentrate bottle costs us about $12, makes 5 gallons. So I gave all my guys, bottles of that, one of those little kids cough medicine spoons, it's the right amount. Pour it in a 32-ounce spray bottle and spray anything you want with it. Like I said, no odor was the biggest thing for me, because anybody in an office building smells something weird and all of a sudden there's a problem. So
yeah, no, that sounds great.
Casey, are you listening in?
I'm here, Brad.
So how does all this compare to what's going on in Ontario?
We don't have COVID.
Oh, that's right. Nobody can leave their home. I forgot.
That's right. We're all locked down here and they don't let us out in the sunlight. But yeah, no, very similar. Obviously, ASHRAE is our guiding institution here as well. And yeah, we've done some MERV 13 upgrades. I don't think we're going to see as much uptake on the general office side yet, because the vast majority, like if you drive through Toronto, you can actually drive through Toronto now. Nobody's going into the offices, so we may see more later on. But we are, finally, I think where America was 4 months ago in the vaccination program, we were one of the laggards in the group. So we're getting vaccines out, and that's helping us from that aspect. But the big challenge I see, and I really would love to set up economizers with the air flush and all that stuff. The challenge is always getting the balance right. When you look at a 20%, it's a nonlinear graph on an economizer, right? So you open it up 5 to 10% on the stroke, it might be 25 to 30%. So we're not measuring effectively. Like we can do that dead of winter, peak of summer, we could put sensors and thermometers in and get those tweaked. But yeah, for the most part, we've had some success. We've sold some UV lamps here and there, mostly to treat the coils. But what we have found again is as people start to price this stuff out, then they start to hesitate again, because our biggest transfer of COVID right now has been in the factory type environment where there is no true makeup air or any of that stuff, right? They're just working side by side, or refrigerated plants where they're shoulder to shoulder. But this is always, you know, you got to pull all this information together as you're doing, and we can take that forward, because at least we can debunk some of the stuff for the customers where, you know, I did find the graphing interesting there on the relationship between a MERV 8 and MERV 13 and where your pressure drops are. Because yeah, the easy thing to do when you've got 100 things on the go is to say, well, it can't handle the pressure drop. What's the next fire I got to go put out? But yeah, it is interesting to be able to have a confident conversation. And, you know, mathematically, it is challenging for us to see some of these things in 20% versus 30% if I put in a MERV 13 versus one of the others. But really good information there from that perspective. And if we could get everybody to MERV 13s, as was pointed out, you know, it's inventory is a little bit of a challenge across the world right now.
Yeah.
For sure.
Well, if there are no, oh, go ahead, I'm sorry.
No, I was just gonna say it's a great input, and you know, I think it sounds like you guys are doing some really good things out there. Brad, I'll also send you the slides in a PDF, as well as the checklist that was requested. And again, really appreciate the opportunity to talk to everybody today.